All right, we've all been there, right? Staring at a coding interview question that just seems impossible. Well, today, we're going to crack open a couple of classic brain teasers that all revolve around one of my favorite data structures, the linked list. Let's get into it. This right here is the core puzzle of a linked list. It's a constraint that forces you to get really, really creative. So before we jump into our first problem, let's make sure we're all on the same page about the rules of this particular one-way street. I want you to imagine you're on a scavenger hunt. Each clue you find only points you to the next location. There's no map, there's no going back to the last clue. Or think of it like a train. You can only move from your car to the next one, forward, forward, forward. That, in a nutshell, is a singly linked list. So yeah, the big idea here is that it's a one-way street. Every single item in the list, we call it a node, has a pointer that says, hey, go this way to find the next guy. You only know what's immediately ahead of you, and you can never go back. And that limited information is exactly what makes these problems so tricky, but honestly, so much fun to figure out. Okay, let's dive into our first puzzle. And this one, when you first hear it, it sounds like it completely breaks the rules we just laid out. So think about this. Normally, if you want to delete a node, you just find the node before it and tell that node, hey, just skip over this next one. Easy. But here's the catch. We can't get to the previous node. We're stuck. We're literally on the island we need to remove with no bridge back. So how in the world do we do this? And the solution is it's just so clever. It's this awesome bit of logical sleight of hand. Instead of trying to delete the node we're on, we turn it into a perfect clone of the node after it. And then we delete that one instead. It's a brilliant, brilliant workaround. Let's walk through this copycat trick. So first, you look at your target and its neighbor right next door. Step 2, you do a little identity theft. You copy all the neighbor's data into your target node. Then, for the final move, you rewire your target's next pointer so it completely leapfrogs over that original neighbor. And just like that, the neighbor is cut off, and our target node is now a perfect imposter. It wasn't deleted, it just changed its identity. Now, of course, there's a catch. This amazing trick works for any node in the list, except for the very last one, the tail. And why is that? Well, because there's no next node at the end of the line. You can't be a copycat if there's no cat to copy. Okay, so that first trick was all about changing a single node's identity to solve a seemingly impossible problem. Now, let's level up. Our next puzzle is about rotating an entire linked list. Picture taking a whole chunk from the front and just plopping it right at the end. Now, you could absolutely do this slow, brute force way. Take the first node, move it to the end. Take the new first node, move it to the end. And just repeat that k times. But if your list is huge, that's going to be painfully slow. We're talking O of n times k complexity. Imagine a list with 1 million nodes and you have to rotate it 1,000 times. You'd be doing 1 billion operations. No thanks. There is a much, much smarter way to do this in a single pass in just O of n time. So this is where we have to think outside the box again. How do we do this without moving things one at a time? What if, just for a moment, we could change the very shape of the linked list itself? And that's the key. That's the big insight. We stop thinking about our list as a straight line with a start and a finish, and we temporarily turn it into a circle. So here's how this circular trick plays out. First, you find the very end of the list, and you just connect it right back to the beginning. Poof! Now you've got a loop. Next, you just walk along that loop k spots to find where your new tail is supposed to be. The node right after that one, that's your new head. And for the final step, you just snip the connection right after your new tail, and boom, the circle is a line again, perfectly rotated. So after looking at these two puzzles, what's the big takeaway here? It's not really just about memorizing algorithms, is it? It's about a whole different way of thinking when you're stuck. What's so amazing about both of these solutions is that they don't just shuffle data around. No, they creatively manipulate the pointers, the actual connections, the fabric of the list to solve these problems in a super efficient and, frankly, really elegant way. And that is the kind of creative problem solving that's going to make you stand out. It's not just about knowing the rules of the game. It's about understanding them so deeply that you know exactly when and how you can bend them to your will.